10 minutes ago. A piece of data landed on the desks of astronomers that made several of them stop what they were doing and read it twice, because for the first time, the James Webb Space Telescope had pulled a detailed signal out of an object so strange that scientists are still arguing about what it actually is. Not a picture of a black hole, not a shadow, a signal, light with a fingerprint on it, coming from somewhere so close to the edge of a black hole that nobody expected to ever read it clearly. Now, before you get too excited, let's be honest about something, because a good story has to survive contact with the truth. Nothing can send a signal out from inside a black hole. Not light, not radio waves, not anything. Once you cross the event horizon, physics as we understand it says that boundary is one way only. So when we talk about a signal from a black hole, we are not talking about a transmission mailed out from inside the abyss. We are talking about something almost as strange. Light escaping from the last possible inch before the point of no return. Squeezed, twisted, and reshaped by gravity so extreme that it carries the fingerprint of the black hole itself. That is what Webb just managed to catch. And once you understand what that fingerprint actually says, you will understand why astronomers are calling it one of the strongest pieces of evidence yet for something they have been chasing since the telescope first turned on. To understand why this moment matters, you have to go back to 2022, the year Webb opened its eye on the deep universe for the first time. Almost immediately, astronomers started noticing something odd scattered across its earliest deep field images. Small, extremely distant, and strikingly red points of light. Thousands of them. They did not look like normal galaxies. They were too compact, too red, and too bright for their size. Scientists gave them a name that sounds almost too simple for how much trouble they caused. Little red dots. And for the next few years, little red dots became one of the biggest unsolved mysteries in modern astronomy. Nobody could agree on what they actually were. Some researchers thought they might be an early, unusual population of galaxies, packed unnaturally tight with stars. Others thought they might be something nobody had ever confirmed before, a completely new class of object sitting somewhere between a galaxy and a single, collapsing star. The debate went back and forth for years, because from a distance, a compact cloud of young stars and a feeding black hole can look confusingly similar. You need more than a picture to tell them apart. You need to break the light down and read what is hiding inside it. That is exactly what a team of astronomers did with an object now known as Glimpse 17775. It sits behind a massive galaxy cluster called Abell S1063, whose gravity happens to work like a natural magnifying glass, bending and brightening the light from anything positioned behind it. Webb was not even pointed at this object on purpose. Astronomers were using the cluster to study a completely different population of stars, and Glimpse 17775 simply happened to be sitting in the background of the data. When researchers went back and pulled its spectrum out of the noise, they got the deepest, most detailed reading of a little red dot ever recorded. Over 40 separate spectral lines came out of that light. 40 independent pieces of physical evidence, all pointing in the same direction. According to the team, led by astronomer Vasily Kokorev at the University of Texas at Austin, those 40-plus lines line up with a very specific picture. Not a young cluster of stars. A supermassive black hole, wrapped in a hot, dense cocoon of gas, feeding violently on its surroundings. The gas cocoon absorbs and reshapes the light coming from just outside the black hole's edge, stamping it with a signature that a simple star cluster could never produce. In other words, scientists did not just see a red dot anymore. They read a message written in light. And the message said, there is a black hole here, close enough to its own event horizon, that its feeding is warping the spectrum around it. That is the signal people are talking about. Not something impossible escaping from inside. Something almost as remarkable. A clear voice coming from the very last layer of space before the darkness begins. If that were the only strange black hole story Webb had produced recently, it would already be enough for an entire documentary. But it is not the only one. In fact, in the same stretch of months, Astronomers using this telescope pulled off 3 other discoveries that, stacked together, are starting to rewrite how black holes form, grow, feed, and even move through the universe. Let's start with one of the strangest. A black hole that appears to be running away from its own galaxy. In 2025, several research teams began publishing images of oddly straight lines of stars cutting across galaxies, structures that did not fit any known process of galaxy formation. Galaxies twist, swirl, and curve because of gravity and rotation. They do not normally draw perfectly straight lines through themselves. One paper, led by Yale astronomer Peter Van Dokkum, focused on a distant galaxy where Webb had photographed an unusually bright contrail, a streak of compressed gas and freshly formed stars stretching, roughly 200,000 light-years across, that is longer than the diameter of our own galaxy, drawn in a single straight line. The explanation researchers arrived at is almost cinematic. A black hole with a mass around 10 million times that of our Sun appears to have been ejected from its galaxy, and is now traveling through space at almost 1,000 kilometers per second. As it plows through interstellar gas, its gravity compresses the material directly behind it, igniting a trail of new star formation in its wake, like a ship leaving a glowing wake across a dark ocean. A second, similar case was found cutting across a galaxy called NGC 3627, this time linked to a black hole of around 2 million solar masses, moving at roughly 300 kilometers per second. These are being called runaway black holes, and the evidence for them did not come out of nowhere. For years, scientists studying colliding black holes through gravitational wave detectors had noticed something curious: pairs of black holes with oddly mismatched, randomly oriented spins. That kind of asymmetry is exactly what you would expect if 2 black holes merge violently and the resulting object gets a powerful gravitational kick, flinging it out of its host galaxy entirely. Webb may now be catching the visual proof of that theoretical kick in real time. A black hole that got shoved out of its own galactic home and is dragging a trail of newborn stars behind it as it goes. Then there is a discovery on the opposite end of the spectrum, literally invisible. Astronomers recently confirmed what they are calling the most distant dormant black hole ever measured, sitting inside a galaxy more than 10 billion light-years from Earth, in an object catalogued as MRG M0138. The word dormant matters here. This black hole is not actively feeding. It has no glowing disk of gas around it, no dramatic jet, nothing bright enough to give away its presence directly. In every wavelength of light Webb can detect, it is completely invisible. So how do you weigh something you cannot see at all? The team solved that problem by borrowing a technique normally used on much closer galaxies, tracking the motion of the stars swirling around the black hole, rather than trying to see the black hole itself. A star caught in a black hole's gravity moves in a very particular way, and by measuring how fast those stars are whipping around the galaxy's center, astronomers can calculate the mass hiding at the middle of that motion, invisible or not. To make the measurement possible at such an extreme distance, they relied on gravitational lensing again, using a foreground galaxy's gravity to bend and magnify the light from MRG M0138 by roughly 30 times its normal size. Once they tracked the stellar motion through that magnified image, the number that came out was staggering. A black hole with a mass of roughly 6 billion times our Sun, sitting silently, invisibly, at the heart of a galaxy from a period of the universe most telescopes simply cannot resolve in this kind of detail. It proves something important. Some of the biggest black holes in the early universe are not announcing themselves with light at all. They are simply sitting there, massive and dark, and the only way to find them is to watch how everything around them moves. Now flip back to the opposite behavior entirely. A black hole caught in the act of eating, at the center of a galaxy called NGC 4696. Webb captured unusually detailed images of gas being funneled directly into a supermassive black hole's feeding disk. A vast filament of material stretches inward from the surrounding galaxy, narrowing as it approaches the center, before spiraling into a spinning disk roughly 800 light-years wide. Inside that disk, Gas is racing around the black hole at speeds up to 600 kilometers per second. This is not a still photograph of gravity. It is closer to watching a slow motion video of a black hole's next meal being delivered directly to its table. The material funneling inward, compressing, accelerating, and eventually crossing into the extreme environment, right at the edge of the point of no return. And then there is the discovery that pushes the entire story back to the very beginning of time itself, an object called Canex LDZ 8.6, confirmed by Webb to contain an actively growing supermassive black hole inside a galaxy that existed just 570 million years after the Big Bang. To put that in perspective, that is roughly 4% of the current age of the universe. A supermassive black hole, already feeding, already growing, that early. This connects directly back to the little red dot mystery, because Canex LDZ 8.6 belongs to that same strange, compact, extremely red population of objects. Researchers now believe this discovery links the earliest black holes ever observed to the bright, powerful quasars we see much later in cosmic history, essentially catching one of these objects in an early, in-between stage of its growth, a missing piece connecting how the universe went from having no black holes at all to being filled with monsters billions of times the mass of our Sun in a relatively short amount of cosmic time. So take a step back and look at everything on the table at once. A signal pulled directly from the layer of gas wrapped around a black hole's feeding edge, 40 spectral lines deep, confirming what these little red dots actually are. A black hole caught mid-escape, dragging a 200,000 light-year trail of newborn stars behind it as it rockets away from its own galaxy at nearly 1,000 kilometers per second. A completely invisible black hole, 6 billion solar masses, detected only by watching how it silently bends the motion of stars around it, 10 billion light-years away. A supermassive black hole caught in the act of feeding, gas visibly funneling inward into a spinning disk 800 light-years wide, and a black hole from the dawn of the universe itself, already massive, already growing, just 570 million years after everything began. None of these are separate, unrelated headlines. They are pieces of the exact same puzzle, observed from different angles. How do black holes form so early? How do they grow so fast? What happens when they get kicked out of their galaxies? What do they look like when nothing but starlight gives away that they are there at all? And what is actually happening in that last sliver of space before the edge? Close enough that Webb can finally read the signal written into the light itself. For decades, black holes were the ultimate blank spot in astronomy, regions defined entirely by what we could not see. Webb is slowly turning that blank spot into a readable page, not by looking inside the black hole. That will likely always be impossible, but by getting close enough to the edge, sharp enough in detail, and sensitive enough in its instruments, to catch every trace of light these objects leave behind as they feed, escape, hide, and grow. And this is very likely just the beginning. Webb has years left in its mission, and every one of these discoveries so far has come from scanning a tiny fraction of the sky. If a handful of pointed observations already produced a runaway black hole, an invisible 6 billion solar mass giant, a spinning feeding disk, and a spectral fingerprint confirming the true nature of an entire mysterious class of object, then the real question is what is still sitting out there, unexamined, in the parts of the universe Webb has not looked at yet. If this kind of story is the reason you keep coming back to this channel, make sure you are subscribed, because black holes are about to become one of the most active areas of discovery for the rest of this decade, and you do not want to miss what gets caught next. Let me know in the comments which discovery surprised you the most. The runaway black hole leaving a trail of stars behind it, the invisible giant detected only by the motion around it, or the signal pulled directly from the edge of a feeding black hole 4 billion light-years away. And if you want to go even deeper into how astronomers are mapping the invisible universe, there is another video linked right now that you need to watch.